Hello again, guys. We're back for 11.5 discussing parallel lines and triangles. We start here with a postulate that we've seen before. It's our parallel postulate. It tells us that through a point not on a line, so our line here is line L, through a point, our point P, there's only one line parallel to the given line. If we skew this at all, it will become not parallel. So this has to be perfectly the same direction as our other line. And we're actually going to use this postulate to work forward then from there, dealing with triangles. And it might confuse you how parallel lines relate to triangles, but you will see here in just one moment. So this theorem right here may seem a little simple. The triangle angle sum theorem states that the three angles of a triangle will always sum to 180 degrees, but some people still don't quite understand why. And there's a neat little trick with a piece of paper where you would make a triangle in a piece of paper and then cut it across one way, cut it across the other way, and then match up A, B, and C. Now there's another way that we can actually do that, and we're going to prove why this theorem is true. Alright, so you guys have this proof solved out in your notes, but I would love if you would to take a sheet of paper or something, cover up the statements and the reasons, and try to think through it on your own before uncovering it. So the first thing that always happens is we look at our given and we look at what we're trying to prove. So our given is we have a triangle ABC. That's it. Then I have angles 1, 2, and 3. Now 1 and 3 are exterior angles to the triangle, but I'm trying to show that they all equal 180 degrees when added up together. You should be able to start to think about, well, we have a straight line here, PR, and these three angles are the only three angles on that straight line. So we drew PR through B parallel to AC. Now parallel to AC is very important here for how 1 and 3 are going to work in my triangle coming up later. So then what we can see, because of that straight line, is if I combine angles 1 and 2 and just look at the angle PBC, so I've kind of highlighted that angle there, and angle 3, we can make that a supplementary angle pair because angles that form a linear pair are supplementary. Now, of course, we have 3, but you can always combine angles to look at them as there were fewer. Now, because of the definition of supplementary angles, what it means to be supplementary is that they add up to 180 degrees. So we can go ahead and write it out like this. Because we had originally combined angles 1 and 2, we can now use the angle addition postulate to restate angle PBC as being the addition of angle 1 and angle 2, which then, because up here I used PBC, I can use that same statement but instead replace angle 1 and angle 2 in for angle PBC and add that with angle 3 to equal 180, and all we did was substitute. Moving on, angle 1 is going to be equal to angle A, and angle 3 is going to be equal to angle C. Now if we come back up here and look at this for a second, this might be confusing to begin with, but if we extend a couple of these lines, so I'm going to extend this that way, and we have a parallel line up top, and what we have here is our transversal. So angle A is actually the angle that sits on the inside right here. And then we're comparing it to angle 1. Now why would these be the same? Because they are alternate interior angles. We know that alternate interior angles of parallel lines are always congruent. So we can say that 1 is equal to A, and 3 likewise would be equal to angle C, which would be right down in here, would be your angle C on the inside. And again, that is because if lines are parallel, then alternate interior angles are congruent. And the second to last step, if angle 1 is equal to A and angle 3 is equal to C, actually now we're just stating the measure of the angles. So remember that little M in the angle symbol means the measure of the angle. So congruent angles have congruent measures. And then just by using the substitution property, we can go ahead and plug in that angle A plus angle 2 plus angle C will equal 180. We've got A here, C there, and the angle 2 is really like our angle B. Doesn't matter, we can just call it 2. So there we have it. We've proven that in any triangle, our three angles will add up to 180, and that'll work no matter what, as long as you have a baseline here and you draw another line parallel to that and work through the proof just like this. Now be ready to do that on a test if I ask you about that. But because we know this theorem to be true, we can now use this theorem to always find the third angle of a triangle. Now hopefully you guys have already had some practice doing that, but if not, that is why we're allowed to do that. So now go ahead and apply that theorem to find your missing angles here in example 1 and example 2. Come back and get the answer. So then by applying that theorem, we can set up that my two angles that I am given and my third angle will then equal 180 degrees. So then I add up my like terms and still have angle 1. I can subtract from both sides and then I find that the measure of angle 1 is 30 degrees. Likewise over here we can do the same thing, but hopefully for you it's easy to see that I have an angle of 70 and an angle of 30, so if I were to sum those together that would give me 100 degrees, which leaves my third angle x here having to equal a measure of 80 degrees, and because x and y share a vertical relationship, y would also be 80 degrees. So now we pause for just a moment to talk about the exterior angles in polygons, and more specifically triangles, because that's what we're dealing with here. So we know that all three angles in a triangle add up to 180. So this purple, the missing angle, and angle 2 and angle 3 would add up to 180. But what we also know is that because this purple angle and angle 1 form a linear pair, they would add up to 180. So what we see is that, and let's talk about some how we name things really quick. So remote interior angles, pause for a second to read through this, make sure this makes sense. So now I've got some color coding here. Our exterior angle has then two remote interior angles that correspond with it. And the relationship here, because they share the purple angle plus 1 would be 180, and or the purple angle plus 2 and 3 would be 180, that this angle, the exterior angle, is going to equal the two remote interior angles, the sum of those remote interior angles. We are going to look at that theorem here next. So here's our theorem that nicely states what I was just trying to get at. We have angle 1 is our exterior angle, angles 2 and 3 are remote interior angles, and angle 1 will equal the sum of our remote interior angles. So we have example 5 here, and now we're not quite there in your notes. So let's go ahead, I'm going to skip ahead to examples 3 and 4, and then we'll come back and look at example 5. So in 3 and 4, you want to figure out what the measure of the exterior angle here is, and then the measure of this remote interior. So go ahead, apply theorem 17, write out the math that fits this, and solve for angle 1 and 2. So pause the video now. So here all we are applying is our triangle exterior angle theorem. So we know that the sum of the two remote interior angles will equal the third. So we can set it up just like that. And what we see is when I add up those two, angle 1 is going to equal 98 degrees. Then we come over and apply the triangle exterior angle theorem again, but here this is going to set up a little differently because I have my exterior angle and then only one of my interiors. So I can set it up with my exterior angle and one of my interiors added with my unknown interior. I then would just subtract 59 from both sides, getting that measure of angle 2 would equal 65 degrees. So now we're going to wrap up this lesson by looking at our example 5 here. We're going to say which of the numbered angles are exterior angles. Now be careful. Some people will really quickly say, okay, 4, 5, 6, 7, and 8 because they're all outside the triangle. That's not true. Remember that an exterior angle must have a corresponding set of remote interior angles. So when you're looking for an exterior angle, you need to be able to match it up with its two remote interior angles. So pause the video, try to answer all three of these questions. I'm going to come back and answer them one at a time. Alright, my exterior angles then would be angles 5, 6, and 8. If I look at angle 5, its remote interiors would be 1 and 3. If I look at angle 6, the remote interiors would be 1 and 2. And if I look at angle 8, the remote interiors are angle 1 and angle 2 also. Remember, the remote interiors are always the angles that are not right next to it. So you would go ahead and have those listed out here in B, that 5 matches 1 and 3, 6, 1 and 2, and 8 matches 1 and 2 also. And again, to restate, 6 and 8 have the same ones because they share the interior angle, not remote interior, but they share the interior angle right next to them. So that makes their remote interior angles both 1 and 2, which means that angle 6 and angle 8 would have the same measure, which makes sense because they are vertical angles. So in case I was moving too quick for you there it is all typed out, so you can see the exterior and the remote interior angles that matches it. And that is all I have for today's lesson for 11.5, so please make sure you've worked through all the Pearson work, you've done your practice work, and you come to class and let me know if you have anything at all that is bugging you about this material. We are actually going to skip right through 11.6. We're going to cover that in class. So your next lesson would actually be to move on to chapter 12. So again, please let me know if there's anything I can do for you. Other than that, I will see you guys in class. Have a great day.